welcome to 11-3. This is Area of Polygons. In this video, I'm going to do all the monitoring progress, so it might take some time because we are drawing and you're going to draw with me. But considering there's a formula for everything, kind of like there was in previous sections, it's not really, obviously you need to do the formulas correctly, but identifying how to use the formulas and how to find the different parts is really what's important. So make sure you listen, take notes, ask me questions on the other side of this video. Okay, so let's get started. Everyone turn to page 610. Yes, you should have your textbook with you. You should have your notebook with you. All right, I am going to do 1 through 6. It's the whole section for 11-3, but it starts on page 610, so you know where we're going. And the first thing we're doing is we're actually just going to start off with number 1. There's a core concept that you're going to have to copy down above it. All right, we have the area of a rhombus. So if you have heard of a rhombus before, it's kind of like a square, but not a rectangle. So we have 4 equal sides, okay? But the angles, even though they add up to 360, each angle is not 90 degrees. So it has 4 equal sides like a square, but it doesn't have 4 90-degree angles like a rectangle. So it's nice and tilted, figure not drawn to scale, and we have different diagonals that go from one vertice to the vertice across from it, another vertice to the vertice across from it. So we could call this diagonal 2, we can call this diagonal 1. I wonder if it matters. Something for you to find out. So it says, let's find the area of this rhombus, and we know that diagonal 1 is 4 feet. We know that diagonal 2 is 5 feet. All right, well, the area of a rhombus or a kite is going to be 1/2 diagonal 1 times diagonal 2. 1/2 diagonal 1 times diagonal 2. All right, well, let's go find this area. 1/2, 4 feet times 5 feet. Is it important that I write down the feet in there? Well, 1/2 of 4 is 2, and 2 times 5 is 10. So we have 10 square feet. Are you going to be correct if you don't have the square feet? No, you would not be. What is the area? It's not 10, it's 10 square feet. Okay, number 2. So a kite is actually, it's the same formula, but a kite would be a rhombus, but you pinch one of the vertices and you stretch it. So let's just go ahead and stretch this vertice. I don't know if that's what this kite looks like, but it could be. And this kite, we know that kites have 2 sides that are adjacent, that are congruent, and then 2 other adjacent and congruent sides. So we have a long diagonal, and we have a short diagonal. And the area is still 1/2 diagonal 1 times diagonal 2. So if diagonal 1, oopsies, I don't know, not diagonal, diagonal 1 is 12 feet, and diagonal 2 is 9 feet, then the area is going to be 1/2, 12 feet. I wonder if it's important that I write feet. 1/2 of 12 is 6. 6 times 9 is 54. And now that is the right answer. The area is 54 square feet. All right, so when we have these beautiful quadrilaterals that aren't quite squares, aren't quite rectangles, rhombus, kite, same formula, half the product of the diagonals. All right, take your time, you can pause and you can write down notes that you need to, but I'm gonna move on to example or monitoring progress number 3. But you know what, since it's super duper important, let's copy down the top of page 611 where it says finding angle measures in regular polygons. So here's the thing about a regular polygon and kind of why 360 is such a magical number. We have a great circle. It's just great as a definition, not as an adjective, not as a noun. And we're going to inscribe a regular polygon. So that means that each vertice touches the circumference of the circle. Well, how many degrees are in a circle, right? If we start in the center, we turn around, we spin out 360 degrees. Isn't that the same as the amount of degrees in this polygon? So we have a center here that's called P. And they're giving us two vertices named M and N. All right, so look very carefully, right? I could draw a line from P to M, right? Now, this goes from the center of the circle to a vertice of this polygon. Well, it's also a radius, isn't it? Right? And I can draw another line from P to N, and it goes to this vertice, and it's also a radius. But there's other important lines here. From the center of the circle, straight out to form a 90-degree angle with the side of the polygon, that is called an apothegm. It rhymes with Gotham for you Batman fans. An apothegm. Does it go all the way to the circumference? No, it does not. It goes from the center to the side of the polygon, any side, as long as it forms a 90-degree angle. Okay, I could make another one here, but we're focusing on this triangle here, MPN. Okay, and apothegm. And they're labeling this Q, so we have apothegm, the line segment is PQ. Okay, so apothegm goes from the center to the side. All right, so we then can figure out, all right, well, look at the center of the circle. It's also the center of the polygon. And here is an angle. I'm gonna do it in red, hopefully it comes out. Here's an angle. It's a central angle, right? It comes from the center of the circle. So this angle MPN, it's a central angle. But how could we figure out how many degrees it is? Well, we could take the whole circle and divide. This angle opens up to one side of this regular polygon. And since all the sides of a regular polygon are equal, we have 1, 2, 3, 4, 5, 6 separate sides. So this angle is going to be 360 divided by 6. So this central angle will be 60 degrees, and every central angle will also be 60 degrees all the way around the polygon, okay? So if you want to find central angles, you can take 360 and divide by what we call n, and that is the number of sides. Okay, that was a lot of information. You might want to pause, rewind, go back, make sure you have it. But the idea is that regular polygons can be inscribed in a circle, and if we inscribe something in a circle, we know that the whole thing in the center, the whole degrees have to add up to 360. And then we can break down and find other parts of the polygon, okay? I'm gonna turn the page because I'm running out of room, but we're gonna do number 3 at the bottom of 611. So if you're ready, you can get started in drawing the figure. And of course, we're gonna draw the figure because we have to have a good understanding. All right, so for number 3 and number 4, actually, we have a circle. We have a square inscribed into the circle. Okay, you know, figure not drawn to scale. We're gonna do our best. Square is WXYZ. We have this in the center. Okay, we have an apothegm right here. I shouldn't be giving away the answers, I guess. Okay. All right, so it says identify the center. All right, well, that's easy. The center is P, right? Boom, right in the center. What is a radius? All right, so see if you can say it before me. Start from the center. What is a radius? Well, we could say PX. Is there another good answer out there? I hope you said PY. Good job if you did. All right, what about the apothegm? Okay, is there a line that goes from the center and forms a 90-degree angle with one of the sides? Yup, it's PQ. Don't forget your line segment thing here. Let's be good. It's the end of the school year. Let's be good about our notations. And then finally, can we identify one of the central angles? Well, we know that this is a central angle. Starts at the center. Here's a radius. Here's a radius. So this is a central angle. So we have a central angle of what? X, P, Y. Okay, again, don't forget your angle marker. All right. Now, can we actually find the values of some of these things? Let's try. So number 4, can we find the measure of angle X, P, Y? Okay, I'm gonna write this out. You might know it already, but let's keep in mind, this is a whole circle. and we're splitting the circle into 1, 2, 3, 4 equal parts, right? So some of you probably just blurted out 90 degrees, we wrote it down, good for you. But for those of us that need the way to get there, right? Like you're not always gonna get squares. What if you get a nonagon? What are you gonna do, right? You're gonna need to know what to put down here. Remember, this is the number of sides of the polygon. All right, ooh, now can we find the measure of angle X, P, Q? Oh, okay, so X, P, Q. Well, that's this half of this central angle, and this half, oh, sorry, half of 90 is 45. Okay, XPQ is this half of the central angle. We know the central angle is 90, so the half must be XPQ. Oh, but then what about the measure of angle PXQ? PXQ. Oh, okay, so what about the measure of this angle right here? 45, sorry, oopsies, 45, 90, and then plus what? Sorry, 45, 90 plus what is going to get us 180? Another 45 degrees. And this is a 45, 45, 90 right triangle. And I wonder if that would help us later on if I gave you a value of one of the sides. But we'll table that for now. 360 divided by the number of sides, get sides with a D, gets us the number of degrees of the central angle, and then half the central angle, and then 45 plus 90 equals 135, 180 minus 135, that's the rest of the triangle. All right, let us turn the page, and let's go ahead and copy down the core concept on page 612. All right, so here we have any regular polygon. In this case, they give us a hexagon. All right, and we're going to split it up into 6 equal pieces of a very rigid pie, very sharp pie. All right, we have a beautiful apothem right here, and then the sides. All right, so if we have a regular polygon, the area is going to be either 1/2 the apothem times the perimeter. Okay, so this plus this plus this plus this plus this plus this, or it's going to be, you know, how are we going to find the perimeter if I give you one side? Well, I gave you one side. It's going to be 1/2 the apothem times the number of sides times the length of the side, right? If this is side, this side length S, and we have n sides, or in this case 6 sides, this would be 6s as the perimeter. So these are the same formulas, but we're probably not going to be given the whole perimeter. If you want to find it first because you feel comfortable, go for it. Or you can just multiply it by 6 times it by 1/2 the apothem. So let's figure out. Number 5. Do they give us a hexagon for number 5 on page 613? No, they don't. They give us a pentagon. Figure not drawn to scale. They tell us that the apothem is 6.5 and the radius is 8. All right, I know that's a really ugly drawing. Okay, so what do I need to know to find the area of this regular polygon? I need to know 1/2 the apothem times, and I'm going to use ns instead of the perimeter, the number of sides times how long the side is. Well, I know how many number of sides there are, right? There's 5, so we have 1/2 the apothem times 5, but do I know what the side length is? So here we have a few different ways of getting the right answer. And in fact, the book is going to take you through one way. I'm going to first take you through a different way, and then I'll show you the book's way. So I would honestly like to just use the quadratic, not the quadratic formula, the Pythagorean theorem, right? So I'm going to go get, I don't really want to call this A. Let's call it B, right? So 6.5 squared plus B squared is equal to 8 squared, correct? And we're just going to solve. We got 8 squared, that's 64. Take away 6.5 squared, that's 42.25. You could obviously do this in your calculator. 64 take away 42.25, and then we square root it. So I'm going to write this out for you since I'm not showing you my calculator. B squared equals 21.75. To get B by itself, we have to square root it. So the square root of that is about 4.66. All right, so we know that this little part right here is about 4.66. Well, this little part is half the whole side. So what am I going to do to multiply? What am I going to do to find the whole side? I'm getting ahead of myself. I'm going to multiply by 2, right? If I just found little b, right, part of Pythagorean theorem, this little leg, if I multiply it by 2, I'm going to get, comes out to about 9.33. I didn't type in 4.66 in my calculator. I left it, and then I hit answer times 2 to get about 9.33. So we know that the side is about 9.33. And I can plug it into my formula, and then I'm just going to use my calculator to go ahead and solve that. So 0.5 times 6.5 times 5 times 9.33, and it looks like I'm going to get, I'm a little off from the book actually, about 151.61 square units. They don't tell us what it is, so square units. Now the book's answer is 151, sorry about that, 151.57. Now, I rounded a few times, so that could be one reason why I got a different answer. However, I will also tell you, the book does it a little differently. So I just want to walk you through that. Let's focus in on this triangle right here. Okay. All right, and we know that the formula is 1/2 a times the apothem times the number of sides times the length of the side. All right, how can I figure out, let's still call it b, right? I use the Pythagorean theorem to do it. Well, if I want to, I could actually figure out from the main figure, the central angle has to be 360 divided by 5. That's 72 degrees. But this is half the central angle. If the central angle is 72 degrees, this is going to be 36 degrees. And now if I wanted to find this, and I know one of these sides, I could use, I'm going to use sine in this case. The sine of 36 degrees is equal to opposite over hypotenuse. So to solve for b, I'm going to multiply by 8. I'm just making sure I'm in degree mode. So to get b by itself, I'm going to do 8 times sine 36, and I get about 4.7. Now that gets me half of the side. So let me multiply that by 2, and see, I get about 9.4, right? And here I got 9.33. And so now I'm going to multiply that by 5, multiply it by the apothem, multiply it by 0.5, and I actually get a little bit off still, 152.82. As you can see, there's going to be some wiggle in what we do. All right, you're going to have to be okay, take a deep breath, and be okay that there's going to be rounding errors. All right, if it becomes a huge problem, we'll deal with it when we get there. Okay, if you need to pause, rewind, so that you can review either using the Pythagorean theorem or using sine, cosine, or tan, go for it. I'm going to turn number 6. And, we're not given much information. Number 6. How many sides are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so we have a decagon. I feel like I've never used one of those before. I'm doing my best. Oh, God. You know what? It's okay if my best isn't good enough. Not the end of the world yet. Okay, and we know that S is 7. Okay, let's remind ourselves. The area of this decagon is 1/2 the apothem times the number of sides times the side length. Well, I don't know my apothem, but I know that I have 10 sides and one side is 7. So I'm going to even clean that up a little bit. Half of 10 is 5. 5 times 7 is 35. So if I can just find my apothem, I'm good. Well, let's see. What if this was in a circle, right? So let's take this bottom one here. So I'm going to cut out this slice right here. Okay, picture a circle around. I don't want to make my drawing any messier. Now, if there's 360 degrees in a circle and I took out 1/10 of that, how much did I take out? I took out 36 degrees. Okay, now that's 36 degrees, and I'm looking for the apothem that goes straight down the middle and forms a right angle. So I'm looking for this. And I know that if the whole central angle is 36 degrees, this tiny little part is going to be 18 degrees. So let's zoom in again. Wait a second, though. This whole side was 7. This little part's got to be 3.5. I'm looking for the apothem, and I know that this is 18 degrees. Do I know a function that relates the opposite and the adjacent? Yes, I do. What if I find out that the tan of 18 degrees is going to be 3.5 over my apothem? Variables in the denominator, so we do the switcheroony. Okay, and I'm just going to make sure I do that correctly in my calculator. So that comes out to about 10.77. All right, so if my apothem is about 10.77, and I know I need to multiply 35 times my apothem, my area is going to be 377.02 square, well, approximately square units. Now this is actually the exact answer the book has. I have a feeling if you want to go back for number 5 and redo it with tangent, we're going to get even closer to the right answer. Normally math makes sense, but when we start rounding, we're not really doing math, we're estimating. And estimating doesn't always make sense. That's the problem, okay? So you also have the ability to look at the Big Ideas videos. There's a reason why I had you guys start with those instead of my videos, so that you have another resource in someone else's language. There's going to be problems for you to do along with that. Take your time. Remember to break it down. I really suggest go back, look at what we did for number 6, right? We started with the decagon. We took out a slice. We broke down the slice. This helps us keep track of what is our goal. In this case, we were looking for the apothem. Okay, and I didn't want to make a mistake. You know me, I go fast. If I went fast and I judged it by this green figure, you know I'd probably take that 7 as the side of that. But it's a good thing I broke it down because it made me realize that I was going to use 3.5 and not 7. Okay, so anyway, check the internet for the problems to do, and we'll talk about it when you're done. Get some practice.